Welcome to all. This is a class number, or actually I told yesterday class number. Instead of class 1, I made part 1, part 2. Okay. I think part 3 for analysis of singly reinforced rectangular section, singly reinforced and doubly reinforced. Another 3-4 parts will be there. And for those who are in the RCC group, this is class number, remember, 18. Class number 18A. 18A for you. Okay, that's all. Today's class heading, see, calculation of moment of resistance. So remember, moment of resistance means capacity. Not last time, what you have done? You randomly applied bending moment. That is Roman 1. Roman 2 is, no, don't apply random bending moment. You apply the maximum it can resist. So last time, randomly, like for example, simple language, okay, some may laugh. What is the money matter? It counts. Go and eat randomly, then pay for it. Here, not that way. Before eating, check how much money you have got. You can, how much maximum you can eat. Now, last time, how much you eat, you pay for that one. Now, you should safely come outside. So, you should eat only how much maximum possible for you. Simple language. Okay, so now resisting capacity. Remember, for that one, green color will come. See, currently today green and red both are coming. I tell the reason for red and green. Blue, as usual, is depth of neutral axis for the given section. That is given section. That is the actual depth of neutral axis. Okay. Procedure already given in the part 1. And those who are in the group, very thoroughly explained with a beautiful money matter example. Remember, what I am telling now is only for the group. 1:10, rich and poor. Remember it. Others I will do something else. Okay, start. 2A. Why A? Today I will solve a problem where cross section comes under reinforced. 1 minute. Yes, correct. And next, 2B. I will solve a question when cross section comes over reinforced. 2C. Last time question homework, the series of stresses I will connect with the MR. That is special discussion. Okay, start. Question dictated in class. See, I will tell the question. A rectangular section of a RC beam, 250 mm wide and 600 mm deep, is reinforced on tension side by 2 bars of 16 mm diameter at a clear cover of 40 mm. Next, further, consider the BM to be sagging. Why you require it? See, make a note. Sagging BM, so tension down, compression upper side. Anything, even if it is hogging, maybe next question I may make it hogging. That is not a problem. Then, so this will become your extreme compression edge. Now, from here to here is called D. Question continued. So, I will read the question once again. A rectangular section of a RC beam is 250 mm wide and 600 mm deep. It is reinforced on tension side by 2 bars of 16 mm diameter at a clear cover of 40 mm. Then, taking M25 concrete, see written here, and tar steel of grade Fe 500. Find moment of resistance of the cross section. Okay, start. First write if you want. Moment of resistance of a cross section is the maximum BM cross section can resist. It is such a BM so that neither in concrete nor in steel stress should exceed the limit. But in one of the material, it should reach the limit. If both the material, it is lesser, safe, no doubt. It is not the maximum BM. It is not the maximum BM. For the maximum BM, one material, in either concrete or steel, should reach its limit. Further bending moment you can't apply. I will explain later. Okay, start. B, 250. D, 552. I don't have to explain. 600 minus 40 minus 16 by 2. AST, you already know how to calculate. Pi by 4, 16 square into 2, concrete M25, remember, for which as per IS code, sigma CBC, all explained for the batch, others should know it. Permissible stress in concrete in bending compression is 8.5 Newton per mm square. Search IS code, table number all, I will not write. Tor steel of grade FV500, for which sigma ST, permissible stress in steel in tension, is 0.55 Fy. For FV500 steel, Fy is 500 Newton per mm square. So sigma ST equal to 0.55 into 500 will become 275 Newton per mm square. Required to find the green color, what? Moment of resistance of cross section. Okay, start. First step. I think I already given the steps in the class number 1, part 1. Locate neutral axis. Remember, what you are doing is you are finding distance of neutral axis or depth of neutral axis from extreme compression for the given cross section. Bx square by 2 equal to MAST D minus x. So you require M. In the previous two questions, Roman 1, I gave the value of M. Because there M20, M30 or FP415 etc. are not required by randomly applying bending moment. This time you require properties. Remember, as per IS code, modular ratio M equal to 280 by 3 sigma CBC. Sigma CBC should be Newton per mm square. 280 also is in Newton per mm square. Some people will tell 280 is unitless. Nonsense. 280 has got unit. I told in the group why it has got unit. Others substitute. 280 by sigma CBC is 8.5. You will get how much? What is 2? What is 2 here? I don't know, some other, okay. You will get 10.98 will come. Okay, now substitute. 250 into x square by 2 equal to 10.98, 402.12 into 552 minus x. X will come 123.086. I already prepared the question and wrote the answer there to save the time. I don't want to waste time by calculating here. For you, it does not matter. You solve. Okay, now note. Class, I am telling, this is the actual depth of the actual neutral axis for the given cross section. Why I am telling? Because little later XC will come. Red color XC, depth of neutral axis for balance section. Then some comparison will be there. So in the blue color, what I wrote is depth of neutral axis for actual section. For the given cross section. If blue is not visible, may look like black, but not red color. Now, to get MR, you got two options. I told, same expression for M last time used. Left side M, right side, whatever stress is developed due to M. But left side MR, right side permissible stress. Okay. Either based on compression or based on tension. Note, this is option 1 and 2 only for singly reinforced. But for doubly reinforced later, unfortunately, MR expression based on tension is not easily available. It is available, no doubt. I can solve. There is nothing impossible for me. Someone told earlier, not possible. Possible, but beyond the control. So, doubly reinforced, usually throughout the world, they write expression for MR only based on compression. So, this option of two expressions is only for singly reinforced, not for doubly. Make a note if you want. See, now, consider expression for MR based on C means compression, or somebody may tell what based on compression? Based on how much stress is allowed or permitted for concrete in extreme compression edge. You should write that way. Bx FCBC by 2 D minus x by 3. This FCBC is max permissible, and where FCBC max per is maximum permissible. Why? MR, compressive stress for concrete for given cross section. If you go for symbol, maximum permissible stress in concrete in bending compression, but to understand I will tell maximum permissible stress for concrete in compression. Okay. For given cross section, very very important. Given cross section, underline. Consider expression for MR based on tension, means how much stress is allowed in tension steel. Class AST FST D minus x by 3. This FST is not random stress. Max permissible tensile stress for steel in tension for given cross section. Now, given cross section, I told class. What is here is given cross section. For that, depth of neutral axis is x. Later, balance section, under reinforced, over reinforced, all counts. At that time, I will be using red color. See, XC I will use. This is only a note. Now, before you go to MR calculation, first one corner note you make. All other people who are general public, those who are in the group not required, I told thousands of times. Just a corner note. MFCBC by FST equal x divided by D minus x. This equation should be compulsorily satisfied. That is, once you decide or once you know how much stress will come in concrete, then stress in steel will be automatically known. Or whatever stress comes in concrete and steel should obey this rule. Or if you know how much stress comes in concrete in compression, at that time, how much stress will come in steel, or if you know how much stress comes in steel, you can find stress in concrete class. Or those who are in the group, I will tell you, rich and poor. Sorry, others I can't tell. 1:10. If you remember, those who are in the group, remember the example now. 1:10. All of you know it. What was it? See, the such things in the actual class, in the course, I will tell all those things because everything will be told. But here, since this class is in the YouTube now, I should limit explanation. I cannot keep on telling examples or money matter once again. Then I will talk technically here. For them, to help them, I have gone for simple procedure. Okay, start. Now, I'll do one thing. I'll remove everything from this side. Only thing I require is, remember, when I come this side later, B is known, D is known, AST known, that's all. And only one thing I require is x equal to, because I may forget it, for the next continuation, x equal to, see, 123 point, don't write here, this is for my reference, 86 millimeter. This is for my reference, x 123 point, not 86, okay. Now, I will continue the question here. Now see, when I solve Roman 2b, then also in the board, I will write same thing once again. But I will not explain. I will tell, refer the Roman 1a. Then after getting x value, I will start here. Roman 2a over Roman 2b, this much before the class I will write. All this I will tell, already explained in the previous class. Go through it, including the class note for general public and easy method for group people, 1:10. Don't ask what is 1:10. Okay, start. I will rub and write I will again do one thing. To save the time, I will write everything here, then continue, because time consuming. For you, it does not matter. Understand correctly, that is sufficient. You write everything systematically and solve. Start now. Now, to find MR, we require FCBC permissible or FST permissible. Make a note. Those who want to use this equation, they want FCBC permissible. Those who want this equation, they want FST max permissible. And remember, limit for FCBC as per IS code is sigma CBC. Limit for FST as per IS code is sigma ST. But you cannot randomly write, blindly write, replace by sigma CBC. No. Limitations are there. So you should decide for, that's why I told given cross section. Start. Now, to find FCBC max permissible or add F, actually make a note here. Any one of them will do. You find this one, use this equation, or find this one, use that equation. Both will give same answer. But we will find both. Nodi. First, find depth of neutral axis for a balanced section. Remember, red color. Depth of neutral axis for a balanced section, xc equal to kd. Limit state method, xu and xu max. Here, kd. K is neutral axis constant for a balanced section given by 280 by 3 by 280 by 3 plus sigma st. Now remember, sigma st in Newton per mm square, 280 also is in Newton per mm square. Substitute. You get 0.253. It is unitless. Substituting K, you get the value of xc, kd, 139.656 millimeter. Now, compare your x, whatever you got. Your x we got, actual depth of neutral axis, 123.086. It is less than depth of neutral axis for a balanced section. Remember, whenever depth of neutral axis for the actual section, x is less than xc, cross section is under reinforced. Make a note for general public. Those who are in the group, not required. In the class, I talked 2 hours for that one. Okay. Under reinforced. Or those people who are in the class, money matter, remember, under reinforced. Poor person has got 100 rupees, rich person, 1000 rupees, rich person, 8,000 rupees. Okay. If I will ask the people there, how much the rich can pay? Sir, 8,000. How much poor can pay? He can actually pay 1,000. No. Because of the 1:10 condition, he should pay only 800. 200 rupees will be still with him. So rich will be critical, poor is relaxing. Only for the group. For others, under reinforced section, what happens is, area of steel provided in tension is less than that for a balanced section. In case of balanced section, when FCBC reaches sigma CBC, its permissible limit, at the same time FST, stress in steel, will reach its permissible limit. But under reinforced section, weakness is on tension side. First to reach critical will be steel. So for under reinforced section, steel, stress in steel will reach the critical value, that is sigma st 275. Remember, at that time, stress in concrete will not reach how much? 8.5 sigma CBC. It will be lesser. How much? You will be knowing later. That value I already calculated. It is 7.1873. I will tell you later. Okay. That is, you will be knowing it later that when the stress in steel reaches 275, at that time, stress, that is the critical for steel. See, as per IS code, stress in tension steel here for FP500 should not exceed 275. When it reaches 275, concrete stress will be only 7.1873. You will be knowing later, little later. But its capacity is 8.5. That's all. Suppose you increase the BM further and make the stress in concrete to reach 8.5, by that time, stress in steel will go beyond the limit. It may go to 300 like that. Not safe. Therefore, those who are general, public, group people I don't have to tell. For under reinforced section, remember one thing, which is weaker, steel weaker, critical stress, maximum limit, the stress will reach the maximum limit for the weaker side. In full structure engineering, remember, strength always depends on weaker, not stronger. So lastly, under reinforced section, steel critical. So stress in steel will reach critical, 275, over. Therefore, you can use this equation. This equation, MR equal to AST, FT max permissible, D minus X by 3, substituted, AST, FST max permissible, D minus X by 3, I got MR 56.5, 10 to the power 6 Newton millimeter, that is 56.50 kilonewton meter. So if you apply a BM of 56.5 kN meter, steel will reach the critical stress here. Of course, at that time, concrete will be relaxed. Suppose you see that concrete relaxed. To increase the stress, you can't increase the BM. You should stop the bending moment at this level. Okay. This is MR based on tension. Now, I will rub everything now because now I have got a class. Actually, if the class is not there, I would have used this one. See, I can remove which one? This I can remove now. Already over. Okay, now see. Make a note. Just make a note. One minute. Over. I want to break now. Continue now only because getting late for me. And another 10-15 minutes, cracker will start bursting more and more. Because around 7 o'clock, CVR comes. Okay, now, make a note. Now, you write here, not consider. Right here. See, suppose, make a note. Note. We already found MR based on tension side equation. But, suppose someone wants to find MR based on compression. Okay, no problem. Then, actually remember, question over here. You got the answer. Suppose somebody wants to find MR based on compression. Why important? For WA in post, you have to use this equation only. But plus, extra terms will be there. So then the MR equal to, write once again this formula. Write once again here. Now see, right. Already decided cross section is under reinforced. Therefore, what? I should not use. Therefore, maximum permissible stress in steel, FST max permissible, is sigma ST equal to 275 Newton per mm square. But remember, under reinforced section, critical steel. But remember, FCBC permissible, max permissible will be less than sigma CBC. Or you should make a note, concrete being steel is critical. Just a minute. Concrete is not allowed to reach, like see, 1,000 rupees, 800,000 rupees. Let him pay 8,000. He should pay 800 rupees. Suppose he pays 1,000 rupees, rich person cannot pay. Why? He has to pay 10,000. No. Therefore, even though he has got 1,000, let him pay only 800. So, therefore, how to get? To get FCBC max permissible, what you do? Permissible. Use the relation, right here, use the relation between FCBC and FST. That is what? That is, I should use black color for this one. Okay. That is, I can use here now. That is FCBC divided by FST equal to X divided by D minus X. What do you do? Allow the stress in steel to reach critical. Substitute FST equal to sigma ST equal to 275 Newton per mm square and find what is FCBC. For at that time, what is FCBC? Okay, start. Substituting in this equation M 10.98 into FCBC divided by, it is FCBC, little, okay, divided by FST is 275 equal to X 123.086 divided by 552 minus 123.086. You will get FCBC, one minute, I use black color. You will get FCBC equal to, I noted down, 7.1873 Newton per mm square. That's all right here. That is what? That is the maximum permissible stress for concrete. Maximum permissible compressive stress for concrete for given cross section. Okay, lastly now, to save the time, I will rub everything. I can rub this side? Yes, I can rub this side because I already over. Now substitute. When I rub this side means you don't see that one. You should, 1 minute, Little confusion for pen. You have confusion is for subject. I always tell you the class. Sometime when I use multiple colors, my confusion is for the what? Using the pen here. I don't know what happened to the cap. Okay. I'll do one thing. All I'll remove now. I will continue here. So space. Or now, right here. Substituting in this equation right there. Once substituting in MR equal to, color I will not use, BX, FCBC, max permissible, divided by 2 into D minus X by 3, color I am not using, equal to 250 into X, where is X? 123 correct, huh? 123 point correct, not 86 into 7.1873, that's all, divided by 2 into D. D is 552 minus 123.086 divided by 3. Use the calculator. I will also use the calculator. But remember, it's a serious problem. The pen cap problem. Some cap has gone this side, some that side. Okay. Use the calculator. Because I got confidence in my concept, I don't have to use the calculator. This is a calculator. I will turn the calculator this way and hit some buttons. Answer is 56.50 10 to the power 6 Newton millimeter. That is 56.50 kilonewton meter. Sorry, last closing stages. Because of the pen problem, little this side, that side, color difference. And sound is increasing. So, okay, I will stop now. This is Roman 2 MR calculation A. A means first question in Roman 2, where cross section came under reinforced. In class 4, next class, I will take up same example once again, where it will come over reinforced. There some extra concept is there. Then one more class, the previous class, series of bending moments, I will give the link of that one to this MR. Somewhere in between there, you can see the MR hidden. See, I calculate MR there. So, I have given so many bending moments. One of the bending moment given was actually MR. You can see there. That MR, one question, it was under reinforced section, stress in steel reached critical. Second question there, when it is over reinforced section, I made it over reinforced. There, stress in concrete reached critical. That I will explain in the next class. That is class number 4. Class number 5 and class number 6 will be for doubly reinforced. When I finish those two, this general public class will stop. The course will continue. I already started shear actually now. But remember, all these are from working stress method. Okay. Thank you. We will meet in the next class. That is class number 4. 4 Allah. 1, 2, 3, 4. Yes, correct.